Hello, my name's Lancaster, Southern Cross University. I'm Senior Manager for the Environmental Analysis Laboratory, EAL, in Lismore. I'm in the Environmental Analysis Laboratory now, and what we're going to do is follow on from a video we did on soil testing, the importance of soil testing we put together with Byron Shire Council. Now today we're just going to go through what happens when the soil turns up at the lab. So the paperwork that's required with it, the chain of custody or sample submission form, and then go through what happens with that soil, what we do through the lab process, some of the analysis around the lab, and then going through what the results mean and the importance of the testing for you, the farmer, to really understand what it all happens and what goes on and the results, what they mean. So what we require is a sample that comes in, half fill the bag, and then you seal it up, roll it up, and you may tape that up to send it in the postage. So when it arrives in the lab, we've got that information. That similar information is on what they call a sample submission form or chain of custody. Now often we mentioned before in the previous video, just 10 centimetres, 0 to 10 centimetres for a pasture, 0 to 15 for a tree crop, but then you're looking at whether you do deeper depths as well. I'll just start with showing what happens in the lab. So basically in the lab, we then assign a job number. That then goes on a tray. It goes on the vial so that is stored in the lab for 6 to 12 months. So we always have it dried and ground. So for going back and checking or additional testing if you need it. So in the lab, effectively, I'm just going to do it thoroughly. This is the soil that's from Malangani, northern New South Wales. It's Malangani, it's a hemp paddock from Mara Seeds. It was just collected a few days ago. Effectively in the lab with gloves on, because we're always worried about we don't want to contaminate the sample. We'll break up a sample as much as we can to get a representative sample from a bag that's supplied, and we'll make sure we keep some in the bag so we can go back and look at that if there's any issues. Now this is a hard chocolate brown soil, so it's not something that's going to be broken up easily with hands. We'll get a representative sample, we'll label a tray up 1, 2, 3, 4, and we'll actually put that representative sample in that tray, and then we'll put that in an oven dried, air dried. Now that's 35 to 40 degrees Celsius, and that might take about 1 to 2 days or overnight, or a couple of days at least, depending on how wet it is, to dry it down. What we will do is then just break that up. We'll put it through some general crushers, so light crushing in the lab, and then we'll sieve that at 2 millimetres. So what you end up with is a sieved soil at 2 millimetres, and this is a different job, just an example. And what it is, that's how we analyse it through the lab. So it's sieved at 2 millimetre, so you can see some larger particles there and fine, and we then, all the way through the lab, we take subsamples of that for the analysis. So that's generally how things happen in the lab, and then we go through all the lab analysis. Now typically on a soil analysis in a lab, there might be 10 different extracts we do, where we take a small amount of soil, 1 gram or 2 or 5 grams, and we mix that with an extract solution, and those extract solutions are then separated from the liquid to the solid, and we put through instrumentation. So for this soil, we've picked the heavy guideline, we've looked at your effective cation exchange capacity, and then we're concerned, because it's a heavy soil like this, whether magnesium will be an issue. So when you look at your exchangeable magnesium here, it's 19.2, your guideline for heavy soil is 11.9, so you can see that it's nearly double the exchangeable magnesium. So we go, well, we can't get rid of magnesium, so what can we do? So we have a look at our calcium. Now the calcium here is 58% and the guideline 77.6, so you can see it's low by about 20%. So we've got to build our calcium. We can do that with lime, calcium carbonate, or we can do it with gypsum, which is a calcium sulfate, dolomite. You have options there to build your lime, and then you can work out what quantity of material you need to adjust that exchangeable calcium. When you adjust that, that'll up your pH generally, and you need to then look back at your pH and see if that's an issue. So when we've done this interpretation of your soil, you've added your lime, you've looked at what you're deficient in, you're really looking at these soluble and exchangeables for your immediate effect. So to see what you need to add now, your total nutrients, which is the one we talked about here, on your total stores, that's to look at your longer term, how you can biologically activate your soils to release these nutrients. So in 12 months or 2 years time, you might come back, do a soluble and exchangeable test and see what's really changed in that soil. You might do a leaf test. Now, we haven't talked much about leaf tests, but you might take some leaf and see what's translocated or moved into your leaves to see what is actually functioning in those soils, to see how active your soils are in applying nutrients to get a good productivity. You do your soil test to increase your productivity of your soils, to help your plant growth and to help your healthier soils. So we haven't mentioned carbon yet, but really you want to look at your organic matter because it's one of your biggest nutrients you're looking at to work out, is your soil healthy? How's your system looking? How's your plants looking? And look at your whole system and your whole farming practice. Because what the idea of the soil testing is to work out the resilience of your soil for the health, for combating climate change. If you're not going to go biological or regenerative and change your practices, well, your soil test is really just to add fertiliser. What we're trying to do is encourage you to look at the healthier soil, look at your carbon, look at your organic matter, look at your balance of nutrients as a whole view of your soil. And when you do that, you start looking at, well, if I can biologically activate your soil, bring in some good regenerative practices, I can start releasing this huge store of nutrients I have in my soil. So as you can see, this is really complex. There's a lot of chemical parameters here. We're not doing this just so you can work out how much phosphorus, nitrogen, potassium you can put onto your soils. We're doing this because we want you to be resilient in the future. We want you to have a sustainable farming practice where you're looking at the healthier soil, you're getting these results so you can benchmark your soil, so in future you can look back and see how you've changed your practices, how you've helped your farm, helped your family and helped the environment as a whole.